Good morning, people, boys and girls. I hope you're fine as usual. I hope you're keeping well. Today we are going to look at constructing Gantt charts. So, what are Gantt charts? Well, it's just a graphical way to represent the possible start and finish times of all the activities in our activity network in just the same diagram. The one thing to bear in mind, because this can lead to a little bit of confusion if you're not careful, is that the number scale starts at 0. So the first hour or the first day is the one that goes from 0 to 1, because what it represents is elapsed time. That means time that has already passed. So when you get to 1, that means that 1 day has already passed. When you get to 5, it means that 5 full days have already taken place, all right? So you need to be careful with that. And then we're going to split our activities in rows, and the top row is going to represent the critical activities. So let's see these with an example. Here you can see, forget about the bit on the right for now, just look at the activity network here. We've got a series of activities A, B, C, D, E, F, G, H. And the first thing that we need to do from that diagram there is to identify which ones are the critical activities. Now, if you remember from last lesson, I said that the critical activities are easily identified by being the activities between nodes that have got the same early event times and late event times. So if we start the beginning of the diagram and we move our way from left to right, we can see that A is a critical activity for two reasons. One, it is between two vertices with the same early and late event times, so 0, 0 and 4, 4, and the float of activity A is 0. And if you can remember what float was, check out last lesson. Then is B a critical activity? Well, it's not, because it is not between two nodes with the same early and late event time. So B is not critical. C is critical because it is between 4, 4, 9, 9, and the float there is 0. Is D critical? D is not. Is F critical? Yes, it is, because it is between 14, 14 and 12, 12, and there's no float. The float is 0. E is critical as well. It is between 12, 12 and 9, 9, and the float is 0. H is critical because between 14, 14 and 16, 16, the float is 0 as well. And G looks like it could be a critical activity because it is between 9, 9 and 16, 16. However, the float is not 0. If I do 16 take away 9, I get 7. 7 take away 3, which is the duration of the activity, gives me 4. So G has a float of 4, so G is not a critical activity. Therefore, the critical path of this project is A, C, E, F, H. So those are the critical activities. And I'm going to then move on to my diagram on the right, and A, C, E, F, and H will follow one after the other in that pattern, one right after the other. There is no room for starting early or finishing late, or starting later or finishing later. So they go one right after the other. So we start the project at 0, and we have to complete A, C, E, F, and H. Now, all the other non-critical activities, I represent each one in a different row, potentially. That's not necessarily going to be the case, but here it will be. So then B is the first non-critical activity that we find, so that goes on the second row. It has to start, the earliest it can start is 4, so that's why B, the left part of the rectangle of B, is at 4. Because it's got a duration of 3, it runs from 4 to 7, and that's my solid rectangle, but it has a late event time of 12. So I'm going to extend that rectangle with a dashed dotted line all the way to 12. So what that represents is that B, the earliest it can start is at 4, and therefore the earliest it can finish is at 7, but I could slide it along the dotted line if I deemed it appropriate, if I required that to be the case, knowing that the latest it could finish was at 12. I hope that makes sense. With D, we do the same thing. The earliest it could start is at 7, with a duration of 2. The earliest it could finish is at 9, but I've got float, I've got room for maneuver. The latest I could finish it is at 14, and that's my dotted dashed line there, which means I could slide D anywhere there if I wanted. And finally, with G, I do the same thing. Now, is there anything I want to say? Yes, I want to say something else, sorry. I could use this to say, figure out how many people I may need on the project. And from looking at it, I could say that I only need 2 people to work on this project, because one person could do tasks A, C, E, F, and H, do one after the other. And while that first person is completing the critical tasks, another person could do task B. And when they finish task B, they can move on to D. And when they finish D, they could move on to G. So I only need 2 people there. So you can use this diagram to figure out how many people you may need on the project. Okay, in practice, it may not be feasible to ask one person to work 16 hours non-stop, but it will give you an estimate for the minimum number of people that you need to complete the project. You can read that yourselves. You don't need me to read it for you. Here we have an example. So let's forget about the answers for now. And here we have a Gantt chart. I got my critical activities at the top, A, C, G, and J, and the non-critical activities down there. It says here, which activities must be happening at midday on day 10? Now remember that the timeline means completed time, elapsed time. So from 0 to 9, that means that 9 full days have happened. So halfway to day 10 is halfway between 9 and 10. Okay? So if I draw a line down, I can see that activity C must be happening halfway through day 10. Not activity B, that would have been completed before. Activity D, even though I could delay the start, I cannot delay it enough that activity wouldn't have to be happening halfway through day 10. Same goes for E. Now F doesn't necessarily have to be happening halfway through day 10. It could, but I could also delay it enough so that I wouldn't have to have it happening halfway through day 10. And then H and I, it's clear to see that they're never going to be happening halfway through day 10. Now, part B, which activity may be happening on day 10? Well, we said it would have been F. And then back to, we can use this example as well to figure out how many people I may need working on this project here. So I will need one person to do all the critical activities, A, C, G, and J. I could have a second person, and that second person could do activity B, and straight after, they could be doing activity D. But then I will need an extra person to start working on activity E. So I may need 3 people for now. And then what happens with the rest of the activities? F could be delayed enough so that the third person that was working on D could move on to F. So I don't need another extra person to do F, because once D is finished, they could move on to F. And then to do H and I, well, the second person that was doing B and D, they could move on to H, couldn't they? And I could actually even delay the start of I enough so that that person that was doing H could move on to I, say. Or even, yeah, that was it. So I would need one person to do the critical activities, a second person to do B, D, H, and I, a third person to do E. I may need a fourth person to do F. Something like that, 3 or 4. Hopefully that makes sense. I haven't got pen and paper here. This works a lot better if you actually draw it and you can figure out the slotting of people. I haven't got anything to write on here, but hopefully that makes sense. If not, I'll come back to this. Let me know, please. Right, what else have we got? And that's it. That's how to construct and interpret Gantt charts. I hope you found it helpful. Let me know if you don't, and hopefully we can discuss this. All right, hope you're fine. Take care, and I'll see you next time.